So, welcome everyone to the next session at the Tech Excellence Conference 2024 with Marco Consolaro and Alessandro di Gioia. Marco and Alessandro are both founders, coaches, and trainers at the All-Core Academy and the authors of the book Agile Technical Practices Distilled. Marco tackles complex challenges with XP, Agile, Lean, and domain-driven design. He promotes trust, self-organization, and rapid feedback in high-knowledge domains. Alessandro focuses on clear code, scalable system, and technical excellence. He excels at refining legacy systems and guiding teams towards extreme programming principles. And in this session, they're going to show you how to use test doubles in your code without tears. Feel free to write any question and comments in the chat so we can discuss them after the session. But now I hand over the mic to Marco and Alessandro. The stage is yours.
Thank you very much. Thank you very much. And so this session is called Test Doubles, but without tears, right? Because many times it's very, very difficult to use test doubles without making a mess, and then we want to cry, right? So let's see how to do it without tears. I am Marco Consolaro, and here there is Alessandro Di Gioia, my business partner. He's gonna come back big later when it's time to code, because of course there will be some live coding, right? Otherwise it's too boring. But let's start this presentation with our taxonomy about test doubles, right? Why do we call it test doubles? Well, we call it test doubles from Hollywood, right? Every famous actor has his own double, right? Because if they do a dangerous thing, the real actor risk to get injured, and that's too expensive. We cannot risk to injure the real actor. So what do they do in Hollywood? They put there a double. So if the dangerous thing, the double, get injured, no one is too scared, right? It's not $1 million actor, so he can get injured. So in our test, we borrow the same name and we call them test double. Why? Because they are not the same thing. They are not the real thing. They just look like the thing. They just implement the same interface. They look the same, but they are not. And we differentiate several kinds of test double, right? First of all, we have what we call dummy. Dummy is a kind of test double that we essentially just using the constructor or to fill a parameter in a method, but that is not in use in the logic of our test, right? So they are not common in well-designed system, right? If we have a dummy, it means that in some particular situation that object is not used. So it's not the instance is not very cohesive, right? And we can improve the design. But sometimes we cannot afford to do that. We still need to test our thing. So we can use what we call a dummy. But the most interesting are the other kind of test double, right? For example, we can have a stub. We call a stub the test double that responds to call with some pre-programmed output, right? They need to be set up for every test because every test needs to create a context. If there is a dependency to this stub, the stub needs to answer with some clear data in order to set up the test correctly. If we call it stub when we use a framework. If we do it manually, and usually when we do it manually, they are very custom for our situation, we call them fake. Right? So stub and fake usually responds with pre-programmed data. The other big family of test double is what we call mock, right? Now, in some situation, There are people that call every test doubles mock. We like to call mock only the kind of test double that we use for verify that the call happened in a particular way. Right? So for us, the mock is where we set up the expectation and verify the behavior at the end. Right? And if we do it manually, sometimes, I remember back in the day, I remember when these frameworks were expensive and the business didn't want to give us extra budget for the mocking framework, right? They say, now you already have the budget for ReSharper. It's already a lot, right? So no budget for mocking framework. And then we had to do it manually, and then we call them Spy. A mock made by hand is called Spy. Once upon a time, we called them poor man mock, right? Because if you didn't have money, you had to do it manually. Now we are lucky; all the main frameworks are free and open source, right? So this is the taxonomy. Essentially, it looks a little bit like this, right? They are all test double. Some of them are dummy, some are stub and fake, and some are mock and spy, right? This is our taxonomy. But how do we use them? So how can we understand which one is the correct one to use? Well, to understand and to have a nice heuristic on which of these kind of test double to use, it's very useful to look at a very interesting principle, which is the common query separation, right? If we look at our method from this angle, we can always understand if a method is a command of a query, right? We want to keep this kind of method as much separated so that we can always identify if a method is a command or a query. What does it mean? Oh, there are methods that change the state, like command. Oh, commands are methods that change the state. So if we trigger something that makes a change to something else, that is a command. Instead, if we have a method that just returns data, that is a query. And if we keep these two kinds of methods separated, when it's time to choose which test double to use, it's pretty easy to do that, right? Why? Because let's see, if we have a query, well, a query is going to return as some data. So if we have an external component or an external collaborator that gives us some particular data in order to set up a particular test, we can use a stub, right? We use stub for queries. So we program the stub and get it to set up the test, to arrange the test with the right data that we need in that situation. Instead, if we have at the end of our test, usually we trigger a result, or in the case of our exercise, we do a transformation that needs some data to be performed, we can verify that it has been called with a very well-defined parameter, for example, right? And that's what we do with a mock, right? So if we have commands in the assertion phase of our test, we can use mock to verify that something has been triggered correctly. So let's see some guidelines about our test doubles, right? Because test doubles are very powerful, but with great power, we need great responsibilities because it's very easy to make a big mess. So what's important when we use test double? Well, first of all, we want to use test double only for classes that we know, that we own, right? Once upon a time, I remember back in the days, I was trying to stub the HTTP request, right? So now that is it was a very interesting try, but I never achieved to stub it correctly. Why? Because I was not in control of the object HTTP request. It was doing things I didn't even know. And so you can't really reasonably do a realistic job in that way. Actually, it's very dangerous because we don't know how it's supposed to be used. So how can we do in that situation? Well, if we need to set up a test in such a situation, what we can do is to create an interface, a very small abstraction layer between our code and the external object, where we can intercept the calls and actually stop just that thing abstraction layer, right? We can create a proxy or a facade. And this is true also if we call, for example, an external API, right? If we call the API directly in our code, we can't use this trick, right? Because the call is, our class depends directly to the call. So what we suggest is to put a proxy in between, a small abstraction layer, so that if we need to receive some particular kind of data from there, we can stub it and program it with the data that we need. Or if that's where we send the final result of our computation to notify a change of state, we can mock it and verify that the proxy has been called with the data that we expect. Another important suggestion about our test is to verify as little as possible in a test, right? Here it's not different than a normal test. We want the specification to be as precise as possible, but not more precise. What does it mean? That we do not want to test implementation details, right? We need to be aware and treat our tests as much as a black box as possible and just test the trigger of the method and the parameters inside. We don't want to test implementation detail, otherwise our tests get coupled to the implementation, and if we want to refactor the test is going to break, and that triggers the bad feedback loop, right? So the tests are breaking too quickly, so we don't want to do the refactor, otherwise we break the test. It takes more to fix the test than refactor the code, and so we keep the code suboptimal and so on, and so our design with time gets worse. No, we want to have tests that don't break when we refactor, so that we can refactor as often as possible. Another guideline is don't use test double if you don't need it, right? If we have an isolated object that doesn't have external collaborators, there's no need to use test double, okay? So it's not the difference between mockist, London School, Chicago School, Classic, no. Every technique has its own context, which is ideal. And if we don't have collaborators, then no need to use test double, right? Aggregates, entities, and generate the object that stays in our domain model usually don't need to be tested in this way. Attention, careful, because the same test double can act both as a query or a stub or as a command and a mock, right? It's resolved at a method level, right? So we can have, if we have an external collaborator, which we ask data from, and then we send back a command for notify a result of something that acts as a stub and as a mock at the same time. And it's perfectly fine, okay? Another important guideline is don't add behavior inside test double, right? Sometimes we write fake spy, less restraint from writing crazy engine inside our fakes and spy. We want to write the obvious implementation, self-explanatory, something that clearly is simple and works. We don't want to go crazy inside our test doubles. And actually, we don't want to add behavior, right? Another important guideline is use test doubles only for immediate neighbors, right? Sometimes I've seen this situation where we have a test double that we set up to return another test double, which we set up to return another test double, that then is the one where we set up to return the data. If we see ourselves engineering a test in this way, let's stop, right? Stop straight away and see if you can improve the design. Chances is that we can improve it because this is a clear situation where we violate the law of Demeter or the tell-don't ask principle, right? It means that we are doing dog dot body dot tail dot wag, right? Message chain. It should be dog dot express happiness, and how the dog do it, it is his behavior, right? It's the implementation detail. So here, if we need to have a stub of a stub of a stub, that's a situation where we might stop and improve the design. Look for code smell like feature envy, inappropriate intimacy, message chain, and fix that before creating this huge, crazy hierarchy with the test doubles. So now, let's see how we can put all this in practice, right? We prepare a kata, which is a Morse Code Kata, right? And the title is Decode the Secret Message, right? We have prepared a page in our website, which is https://alcor.academy/tech-excellence. There is also a QR code. You can see the text of the exercise also in our website, so you can read the exercise while we are coding, right? So here, and this is how the interface should be. So now, check the website, and now I will move as well to our website. That's where we are. Here you find the exercise on the left, and on the right side, we have prepared a page connected to the API that Alex has in its own laptop, right? So we have an API, but now if you hear, let's see if you hear my microphone, if I listen to the secret Morse message, the code, let's stop it because it's very long. And then here we have an API connected that with our exercise, with our Morse decoder, right? But the Morse decoder is not implemented. So our API now says not implemented, right? So the idea is that if we are able to finish the exercise and push it, of course, as you have seen Dave Farley before, we have a continuous deployment in place. So if we are able to code it correctly, the results of our implementation should go straight live. And this API, once you will tell you what is the secret message that we have in this exercise. Okay, so this is the exercise. This is the diagram with the code. So, Alessandro, do you want to begin to explain the code?
Yes. So let's go very, very quickly. We have to implement the decode Morse method, which is the one that takes the Morse message as a string and decodes it so that the iReadText interface, which has a read text method, is able to create an audio file that then we can reproduce on our web API. We defined our ports in here, so we can see very quickly that we have two interfaces that are the collaborators for the Morse decoder. And so this is the kind of the method that we want to implement. We have our tests in here. We are ready for the continuous testing when I save. So let's make sure that everything is working fine and compiling and running. Lovely. So let's start with writing the first test in here. Of course, maybe the AI is going to be a bit too involved. So what is the first test that we can start writing to kickstart the implementation? Well, in here we can verify that our text reader receives the letter A. So the Morse decoder should decode a Morse message with only the letter A. Okay, how do we do that? So there are different approaches to solve this problem. For this exercise, we're going to use a mocking framework called nsubstitute. But eventually, I will show you how this would look like when we are going to use fakes and stubs, so that fakes and spies, so that you can see the difference in the implementation of the test and also the consequences for the design. So let's start with the first assertion then. Well, we need the code text reader. So I read text, coded text reader equals new substitute for I read text. So this is how we create a substitute. Now, this substitute has the role of a mock. For this reason, we are going to set the expectation on the invocation of this method. So we can write decoded text reader received, which is part of the Fluent API of nsubstitute. And then here we can say read text with the letter A. Now, of course, this doesn't happen out of the blue. We have to invoke the actual behavior for this test. The behavior is the Morse decoder dot decode Morse message. As we can see, doesn't take any parameter. We could test the byte array, but it's quite difficult to write assertions for the correct translation of text into audio file. This is the reason why.
Furthermore, Alessandro, how long does it take? Right? We need to take one test, go in our decoder, get the byte array, save it, put it in a file, get our test to reference it. Yeah, it takes more time to do that than write the test itself. It's not a viable thing to do.
Exactly. So now our constructor requires another collaborator, which is the one that provides the message. So Morse message retriever. And the cool thing is that since we are dealing with interfaces, everything else is an implementation detail. We don't care how the Morse message is implemented and retrieved. We only know that that is the source of our message. Message retriever and decoded text reader. Okay. So now we have everything in place in here. Do we? Well, in reality, if we want to just kickstart the implementation, this test could be good enough. But we will see very soon that actually it's not. So it was expecting read text to be invoked with the parameter A, but instead it was invoked with the parameter not implemented. So let's make it pass. Cool. Push force to master, go home. No, not really. We haven't finished yet. Let's commit. Let's write the first test in here. And let's go. Nice. Now we are ready to move forward. Cool. Well, we need to triangulate, but before doing that, let's do some refactoring. Let's move these components at the class level so that we can use them across the whole test suite. Now we can extract these two and move them into the setup. So this way, they're always ready for our future test. Cool. Let's run the test just to make sure that everything's still working. It does. So let's commit and move on. So we were saying we need to triangulate. Very good. So let's write another test, very similar to the one that we just wrote. The code a Morse message with only the letter B. I mean, I'm sorry, I'm not that creative today. So we could be tempted to just, copy paste this and say, well, now we have to just make it pass with letter B. Unfortunately, well, hopefully this doesn't work because we haven't implemented it yet. But the problem in here is that we need to instruct the pipeline that we are building that takes the message from the Morse message and sends the decoded message to the read text. And so we need to do the wiring. For this reason.
So what is the query right here? Where is the message coming from? Right?
Exactly.
We need to find our query.
Exactly. The Morse message retriever dot get Morse message is the one that provides us with the Morse message. So we are going to stub the method that gets the Morse message. So get Morse message returns the representation of the B letter in Morse, which is dash dot dot dot. Now we can run the test. Of course, it's not passing, but now it's complete. And now we can say, okay, so let's actually use our collaborators. Get Morse message. Well, then we have the Morse message. And in here, we can say, well, if Morse message is dash dot dot dot, then return the code text reader dot read text B. Now we are triangulating the implementation. So of course we know that the logic could be improved already. But let's suppose that this logic is way more involved. So we are getting there step by step. So we made this test pass. So let's commit the new test. And now, since we want to triangulate and want to see something happening 3 times, this is a rule of thumb, of course. If you are more experienced, don't waste your time doing this. But if you need to see a pattern emerging, we can just add more examples. And as our tests become more specific, our code becomes more generic. So in here, we can do the same for letter C. Letter C is dash dot dash dot. Let's run it. Let's see it failing for the right reason first. Is it the right reason? Yes, because we were expecting C, but was invoked with A. So we can say if Morse message is dash dot, then return the code text reader dot read text with C. Cool. Let's make it. Let's see if this passes. Okay, it's all green. So we can commit now. We made another test pass. And now we are ready to do some refactoring. Let's start with refactoring the code. So in here, one thing that we can do following the transformation priority premise is the idea of introducing a dictionary so that we have a lookup table in memory that we can use to do the conversion character by character. I like to call my dictionaries in this way because they allow me to think in terms of mapping values, keys to values. So in here we said, okay, letter A is dash that, comma A, and then we're gonna have
dash dot
for B, and then
dash dot
dash dot for C. Okay, so now we can use that instead. And now we can pass the message. Let's see if this refactoring works. It doesn't find a key in our dictionary. Why? The reason is, as I was saying before, that one of these tests is actually incomplete. And this is one of the biggest drawbacks of using Stubs and mocks, because now our tests are so tightly coupled to the implementation detail that we have to modify this step. So we have to instruct in here the framework to actually use the stub. Okay, and now it recognizes it. So this is already, I would say, a smell in our world. But let's move on. So this was a refactoring. Let me commit. Still, we can do even better. We know that test code is first-class citizen, so we can refactor very quickly these tests to make them parametric so that we can write more tests more quickly. The first step is to try to make the tests that we already written redundant. So we can say decode a Morse message, and in here we will have different parameters, couples of parameters, I would say. So the first one is dot dash for A. And of course, in here, we will have the Morse message, and here the string for the expected. Okay. Next. In here, we return the Morse message. And in here, we are going to read the expected text. Let's see. Cool. Everything passing. This is the syntax. So we can get rid of the first test. Let's commit for this refactoring. And let's move on. So now we can do very quickly the same for the other two tests. So dash dot 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 is letter B, and dash dot is letter C. Let's run everything to make sure everything's still okay. Nice. So we can get rid of those tests. Let's commit this refactoring. And now we have a cleaner implementation. At this point, we can move forward to the next degree of freedom. The next degree of freedom is not testing just one letter at a time, but test a word. So more than one letter at a time. But to do that, we need the whole alphabet. So to save time, I'm not going to write all the tests for all the letters. Imagine I did, okay? Or if you want, you can have that as a configuration that you load, and you only have to test that you are loading the configuration. Let's see if everything is
Or
good.
you can do yourself as an exercise at home,
Exactly.
right? Like they used to say at the university.
Exactly. So at this point, we can try to test drive the implementation for more than one letter. And let's say that we want to write the word cat. So cat, the letters in Morse are separated by spaces, and cat is C-A-T. Let's run it. I expect this test to fail. And in fact, it fails because it can't find this key, and that's all right. So what can we do? Well, we can cycle over the Morse message when it's split on the character that separates one letter from another. In this way, we are going to extract the Morse letters. At this point, we can initialize this to string empty and then accumulate over time the value from the Morse letter. Let's see if this works. Boom. So it was expecting cat, but it was doing this. Why the problem in here? Thankfully, we have text, because the Morse letter is the key of our dictionary. So we have to use the dictionary. Morse to letter, square brackets. Let's try. And now we're happy. Commit. This is another test. Let's use these parameters to be even more specific in our comment. And let's move on. What is the next degree of freedom then? Well, first of all, let me do a refactoring. I don't like magic characters, magic strings all over the place. So I'm going to extract this, make it a constant, and call it letter separator. Cool. Let's run to see that everything is still working fine. Lovely. Use a refactoring, commit. So the next degree of freedom is to make sure that we can decode more than one letter, one word at a time. For this reason, we are going to decode the phrase the cat. And as we can see, we need the dash to separate the two words. Let's run the test to see it failing. It fails for the right reason and says, oh, I don't know what this dash is. So let's quickly add it to our dictionary. Nice. And now we can confidently say that this implementation would be good enough to move forward. Let's have a quick look at the implementation in here. As we can see, our test has to be aware of these two collaborators, and even worse, has to be aware of this method and this method and this parameter and this parameter. What happens instead if we have test doubles? For brevity's sake, I quickly prepare them up front. So I'm going to use them here just to show you what a simple spy, a simple fake. So the fake in here, it's basically a simulation of an external system, okay, that is pre-programmed. In here is pre-programmed through the constructor. We are going to impose what is the message through the constructor. The spy in here is just recording what is the text that we passed as a parameter. but you can make it as complicated as you want or as refined as you want. What a test like this would look like then? Well, test like this looks like this one. So in here, this is all the initialization that I have to repeat that we have similarly here in the setup. But look at the assertion. First of all, we don't have to be aware in the test of the fact that we need a message from the fake. And on top of that, the only thing that we have to know about the spy is that the spy has an additional field that allows us to inspect what's going on. Run the test to make sure that we are still happy. Okay, this test also passed. So this is the test with fakes and spies. We are ready to commit. At this point, we are also ready to push our implementation. So from here, we can go on, see the sequence of what we changed. And now the continuous integration pipeline that Marco will show you in a few seconds. We will prove that this code compiles, runs, gets on production, and then it's executed on the website that we shared with you in the beginning.
Yeah, now before doing that, let's see the pipeline running, right? To see our pipeline. It should be triggered, right? In real time, we trigger the pipeline.
Okay, so
you can show the monitor of Alessandro 1 second. That's where the pipeline is running. GitHub Actions. Let's.
It disappeared. You need to share it again.
It's here. This is our GitHub action that
there we go.
How the continuous integration pipeline is deploying on Azure. Once the operation is finished, hopefully we have a working implementation on the website, and you can prove it clicking on the new button once this is done. As I mentioned before, in here we have one part that acted as our fake or pre-programmed collaborator on which we impose a return value. And in here we have the command, the mock, on which we expect things to happen. For people that love functional programming, this is a common sequence of operations when you are retrieving data, unfolding, mapping when you are operating on the data, and then folding, or if you want, sending your data to someone else. In case of functional programming, usually the command part is where you have side effects. So the continuous integration pipeline finished.
And now the web page should tell what is the final message. What is the secret message? Who is live? Is it me? Alex?
I clicked a couple of times. I don't know if you heard it, but it works not only on my machine, but on the website. So this time should be fine. Do you hear it? Okay. If you have any questions.
Yeah, that's the time for questions.
So I'm pretty sure people in here have different opinions about test doubles. Test doubles were very important and very common some years ago, many years ago, where the cost of infrastructure was very, very high. And in that case, making things work could be expensive. So we needed a way to, you couldn't just run another Oracle instance on your local machine and run it. How do you test stuff? Well, licenses are expensive, so we needed test doubles. And back in the day, many people wrote them by themselves. But after a while, some patterns evolved. And for this reason, then, we got the frameworks. These days, we are luckier.
Thanks a lot for your presentation. So we have a couple of questions. Let's just get started with the first one. So Luca asks, hello, question for the speakers. When the design phase is finished, what do you think of replacing mocks with stubs to favor maintenance, for example, for refactoring without changing the tests?
I think the question was replacing mocks with spies, not with stubs. That's what Alex showed exactly how to do it at the end of the exercise. Right?
I would also say that many times writing fakes from scratch can be time-consuming and expensive. Many times they are available for you in memory databases, for example. But the thing that I find most useful is that if I do acceptance test-driven development and outside-in development, it's very likely that you can use just a configuration on your test environment to decide which kind of instance you want to use. The moment you're using fakes or in memories representations, that's when, for example, or frameworks like test containers, you can almost at runtime decide which kind of instance you want. If you want to spin up a container with your local database instead of the production one, it's just a matter of configuration. So it all depends on your circumstances. Usually, if I'm doing unit testing, I don't bother much. Okay. But if I'm doing acceptance test and I want my acceptance test to provide as much value as possible, then on my local machine, I will use local instances, but I don't want to change the test for every environment or write too many tests. So I let the configuration decide in which part of the pipeline run the correct instance.
Great. But also a lot of people commented was this nice TDD observation that the tests are becoming hard to maintain. So we sense there's a smell in the design, and that TDD is actually a great litmus test for design. And if it puts pressure on your design,
So this is a common topic that comes up very often. Test-driven development can't guarantee you that you will have good design. You have to study and practice software design, but it will make clear if the design is not sound. You unfortunately will suffer or not test. That's when you have all the clues that something is not right in your design.
This is also the reason why we start with the test. We start with the test because with the test, we want to exercise our production code as the first thing. And that's when we understand if it's easy to code against or not. So if it's hard to set up the test, the example I said before, you have to create a stub that return a stub that return another stub. Stop, right? If the test is hard to set up, it's hard to do, stop and check the design, right? That is what JB Reismer says, right? It put pressure on your design because that's the first thing that you do. And if it's hard to make, the design is not good enough. So stop, improve the design, go back in your test.
In fact, I like what Kent Beck says. Make the change easy, then make the easy change, which basically means refactor to make adding new value cheaper.
Great answer. So another comment was that unit tests should seldomly require collaborators test doubles anyway.
Well, that depends on the context. So my approach and Marco's approach is to do outside-in test-driven development, which basically means that somehow you're going to interact with the external world. And if you apply a sound hexagonal architecture with ports and adapters or onion architecture, the moment you're able to segregate the external world from the internal world and you have clear separation of concerns, then testing becomes very, very easy. Then it's up to you how you want to isolate from external dependencies. The important bit, which is something that happens very often if you look at legacy code, is that many, many times the dependency inversion principle is violated. So if you want to have a testable system, inject those dependencies. Don't create the connection to your database straight away into your domain model. Otherwise, they have too many reasons to change, and that makes the code extremely expensive to maintain.
Exactly. And then the problem, right? We can see also the problem in another angle. It is true that there's some coupling going on in a certain part of our tests using these techniques. But the other alternative is to have a state-based test, which actually needs to expose the state for the test result. And that breaks encapsulation. So also that is something that is not ideal. So also here we need to understand the context and choose the technique that is more useful in that context. And context means layer of abstraction of your application. So the idea here, I think the more we get toward the domain, the more I use classic tests and state-based tests, the more we go to the edge of the architecture to our ports, the more I tend to use collaboration as such. That's the rule of thumb, if you want.
Okay, great. So we also have a comment here. So my heuristic is to isolate what is slow.
Oh,
so
yeah.
example,
Yes.
IO.
Here, yes, I agree. But it's not really isolate what is low, it's isolate what you are not in control. Right? You're not in control of that. You know what comes up. You know what comes in. But outside there, you're not in control. So the idea is let's isolate that oasis of uncontrollability and check the collaboration in there. Right? For everything inside, we have not that problem.
In fact, one of the reasons why you want to have test doubles is that if you're dealing with external systems, no one guarantees you that the system is always available for you to test. If you're dealing with a payment provider and the product provider is down, what do? You block your continuous integration pipeline? No. You create a fake. You decouple yourself. Dependency inversion is the idea of adding a contract in between so that two things can be decoupled. And together with the Visco substitution principle, dependency inversion principle, you can achieve the open close, which basically makes your code detachable and attachable to something else on top of being extensible.
Okay, great. Maybe in addition to that, isolate with an adapter, don't fake what you don't own.
Absolutely, absolutely. So this is one of the most painful things. If you are coupled with the implementation of a third-party code provider, if they change something, all your tests that know about this dependency have to change. You will spend quite a lot of time updating the test until the next change.
Great. So another thing would be, couldn't you choose to extract the business logic, perhaps even as a dependency that can be tested separately? So this is what I do when the outside tests become ugly.
Absolutely. So in this example, we want to showcase a simple scenario where you are dealing with external dependency. Eventually, you will have to do this. So, of course, if you have a complex domain, the complex domain, especially if you're using an onion architecture or hexagonal architecture, should be completely unaware of external dependencies, completely agnostic. They are not part of your domain. So, in that situation, it's very, very useful to be able to separate those concerns. How do you do that? Usually using interfaces if you're doing object-oriented programming. But if you're using functional programming, your interfaces are the function signatures that can be passed as parameters. And anything that conforms to those function signatures is good enough to be used in your code.
Great. So thanks a lot for your session. It was very insightful.
Can I thank a few people I see in the chat? I want to thank
absolutely do.
Friends. Pedro Santos, first of all, the co-author of our book, I see is there watching on YouTube. Hi, Pedro, we love you. And Michele Brissoni, Leon Hewitt made many questions. He's a friend of mine. Michele Sollecito, our beloved Swiss friend, Patty Koch, and Andrea Laforgia, Enrico Graziani, and Fabio D'Amico. We love you guys.
Thank you.
Thanks a lot. So the next session is going to be Architecture Modernization, Aligning Software Strategy and Structure by Nick Tune. So see you soon there. If you have missed any of our sessions, they're already available on YouTube, and we have lots of upcoming sessions as well, as you can see here. If you want to learn a bit more about software craftsmanship, also check out our products from our sponsors and join us on any social media you can find. So thanks a lot for everyone, and see you in the next session. See ya.
Thank you.
Bye.